Now, let's go to Northern Cape and look at this paper. They said, consider the following chemical reaction. So we're having lead again, Pb forming Pb2 plus, just forgive me there, is Pb2 plus, and then plus 2 electrons. So you're able to see that we have lead is losing electrons. And we said loss of electron is oxidation, which means Pb is our reducing agent, and our reducing agent is oxidized to Pb2 plus. You can see that. And we are having here gaining of electrons, which is a reduction, which is our oxidizing agent, which is now reduced. So those are the half reactions that were given. Now, which one of the following combination is correct for reaction X and Y? So the first column there were given reaction X, but the second column were given reaction Y. So we were looking for the correct. You see, it's very much important to know that we are looking for the correct ones, which means the other three are incorrect. Now let's look. Number A, they are saying Pb is reduced, which is not correct because Pb is oxidized from Pb to Pb2 plus. Its oxidation number has increased. So this is wrong. We don't have to go any further. Number B, Pb is oxidized. Correct. Pb is oxidized. And they are saying H plus is reduced. Interesting. Let's check. The oxidation number of 4H plus here, we're given 4H plus like that. Its oxidation number is plus 1. And then if you go to 2H2O, the oxidation number of hydrogen is still 1. So the oxidation number of oxygen did not change. It remained the same. So it cannot be reduced when it remained the same. Hence, we are going to say this is wrong because H plus is not reduced. It remains the same. Now, let's go. Lead, we have agreed Pb is oxidized. It means it has increased from Pb to Pb2 plus. We agree with that statement. But the next statement says O2 is reduced. Let's go and check. Is O2 reduced? Or what happened there? So you can see that on the reactant side, we have O2 there. And you know that for diatomic molecules like your H2, your Br2, your Cl2, if they are like that, their oxidation number is 0. So the oxidation number is 0 for O2. But on this one, remember group 16, oxygen is group 16, which is minus 2. If it's in a molecule like that one, the oxidation number is minus 2. So you can see that oxygen moved from 0 to minus 2. Hence, we're saying O2 is reduced. So you're able to know that the correct answer is number C, and you choose it with confidence, and you are able to know that you are doing the right thing. So that was the paper from Northern Cape, the multiple choice. Now we're going to the actual question. And if you look at this question already, they say the diagram below represents a galvanic cell. Immediately when you say galvanic cell, you know we are converting chemical to electrical energy. And remember, we're saying this is a spontaneous reaction. It's spontaneous because no energy is added. So we are producing energy. Hence, we say this is exothermic reaction. Galvanic cells are exothermic reaction. So if we say define galvanic cell, you will tell us about energy conversion. To say they convert chemical energy to electrical energy. Under standard conditions. You see the issue of standard conditions. Look at how many question papers that we did, that we're asking you about standard conditions. So you can't make a mistake of going to the exam room without understanding what are the standard conditions. And remember the order. We said start with the 2, which is concentration and temperature. Only if we have gases will include pressure. So it's important that you have that. And then we are given the net cell reaction as 2Fe3 plus 3 magnesium, 2FeS plus 3 Mg2 plus. Let me tell you something. If you look at that overall or net cell reaction, I already indicated that at the left or at the reactant side, we are given a stronger oxidizing agent plus a stronger reducing agent. So the two that we are having here, the other one is a stronger oxidizing agent, the other one is a stronger reducing agent. And if you remember, we said we go to the table to check which one is a stronger reducing agent, which one is a weaker reducing agent. So this is between magnesium and iron. And if you were to Okay, to move to the table quickly and look for magnesium. You will see that magnesium is at the top there. It's at the top there. That is your magnesium there. So meaning that magnesium is a stronger reducing agent. We're comparing it with iron. Please, learners, always be careful, because when you look for iron, there are many ions that we have. And if you check in our question, the ion that we're talking about is iron 3 plus and ion 0, the ion that is not having anything. So please be sure that when you go to the table, you choose the right ion, because you can be excited and choose a different ion, and the whole question now becomes a different question. So the ion that we are looking for is this ion with a 3 plus and ion with no oxidation number. So that is the one, and that is negative 0.06. Now, maybe I can show you another method of understanding or doing this type of question. When you are given two substances that appears in the table with no using table 4b, remember galvanic cell question 8. We are given Mg2 plus 2 electrons. I'm just copying what appears on the table. Maybe you'll see this one much better. And then we're given Fe3 plus 3 electrons, forming Fe. And we said this one is negative 0.06. The other one is negative 2.36. So I hope you got that. You got that correct. So the main thing that you have to deal with is a question of saying this, the one at the top of that table. That's where your anode is. That's your anode. The one at the bottom of your table, that's where your cathode is. So you are able to know that the one with remember this table is a table of standard reduction potential, which means potential stands for ability. Reduction stands for gaining of electrons. So which means this table is a table of ability to gain electrons under standard conditions. So when you read that table, it must have meaning to you to say which one between Fe and Mg, which one has more ability to gain electrons. And if you check always on table 4b, this one, the very same one, your reducing agent that is at the top there on the right, that is the one that will lose electrons, and the one at the bottom will be is where you will find your strongest oxidizing agent. So with no doubt, you can just do your Z there. I like to doing that. Just do a Z. So you can even do that Z on the table to say, okay, what we're given here is Mg like that. Then I make my Z like that, the big Z like that. You see, with arrows, my Z must have arrows. So this Z shows you that the first one, this one at the top there, is going, when you write it going backward, because it doesn't have a higher ability to gain electrons. So it must lose them. Hence, now when you make your Z, it shows you that the first one, we're going to write it as Mg, forming Mg2 plus 2 electrons. And the second one, we write it the way it appears, but with one R. We don't change it, hence the Z is going that side. So it's able to say this one will be Fe3 plus 3 electrons, forming Fe. So you are able to do that. And remember, you can say this one at the top there is A, and the one at the bottom is C. So always when you are counting your alphabets, they will always start from A, B, C, D. So the anode is that one at the top and the cathode at the bottom. So already you will have seen that this is your anode, magnesium is your anode, and iron is your cathode. Don't make a mistake of thinking that your cathode is Fe3 plus. Remember, a cathode, the electrode must be solid. In this case, our solids here is iron. So we have iron and magnesium as our electrode. So those two are our reducing agents. And then we're having Mg2 plus and Fe3 plus as our oxidizing agent. And when it goes to issue of strength, we said when you go down the group on the left, you are increasing the oxidizing ability. You see these arrows all the time. So you can see that iron 3 plus is a stronger oxidizing agent than magnesium 2 plus. On the right, you are having your reducing agents, which means that magnesium is a stronger reducing agent than iron. And if you are stronger, it means magnesium must lose electrons. And then ion will be formed in that case when ion 3 plus gains electrons, because ion 3 plus is a stronger oxidizing agent. So already we have written there the reaction in the anode, which is your loss of electron, which you said is oxidation, pardon me. And then we had our gaining of electrons, which you said is reduction. So you are able to see now that, okay, loss of electrons, when I'm doing the Z method, you write the Z going backward, you're able to say that is my anode, it reverses, but my cathode remains because it has a higher ability to gain electrons. So my cathode will always be, where cathode is, there will be reduction, reaction, or there will be gaining of electrons. Please, learners, I want to emphasize this, that it's not the cathode that gains electrons, because it is the ion. Remember, our cathode here is ion, ion Fe. Fe is our cathode. It's not Fe that is gaining electrons, but it's Fe3 plus. It's the ion of that particular metal in the cathode that is gaining electrons, so that you don't have that, because sometimes in the multiple choice questions, we're able to ask you which one is your oxidizing agent. Then learners will say ion. No, ion is not an oxidizing agent. Remember, the oxidizing agent are on the left of the table, and you follow the arrow. The one that where the arrow is pointing is the strongest. In this case, our strongest oxidizing agent is Fe3 plus. Our strongest reducing agent is Mg. So I'm hoping we are moving together, me and you. So we're able to write the loss of electrons. So we can say magnesium is our reducing agent, and we can say Fe3 plus is our oxidizing agent, because Fe3 plus is reduced. And we can say magnesium is our reducing agent because magnesium is oxidized. So you're able to get that. And then from there, you can even use this to calculate the EMF of the cell, to say the EMF of a cell is E cathode minus E anode. I'm still emphasizing, you write the formula the way it appears in the data sheet, so that we don't have problem. Now your E cathode, we have agreed that minus 0.06 is your cathode, and then your minus, don't forget, is minus 2.36. That is your anode there. And then you are able to say, okay, we have a positive 2.36 minus 0.06. I think that is giving you 2.30 if my maths is doing well. Then you are able to get that, and it's spontaneous. And definitely this is the question that you are going to get in the question. So always, then this method helps you to identify the cathode and the anode faster. To say, when I go to table 4b, I will look for the two that I'm given on the equation. I will write my Z. The first one is my anode, the second one is my cathode. And my anode, I will write it in reverse. My cathode, I will write it as it's going forward. And I'm able to use that information as well to calculate the EMF of the cell. And I'm able to get my answer. And if we go back to the question, you will see that whatever that we were doing is going to assist you. So the energy conversion we have said for the galvanic cell is from chemical energy to electrical energy. And we said the two standard condition will be the initial concentration of 1 mole per cubic decimeter and the temperature of 298 kelvins or 25 degrees Celsius. You will write temperature and concentration in full. The electrode which acts as the cathode, we have already indicated that is ion. That is ion, because the ion 3 plus will gain electrons to form ion. We said already magnesium is a stronger reducing agent, so it will lose electrons to form magnesium 2 plus. So give a reason, because we said the reason here that your ion 3 plus is going to gain your electrons and form ion there. Now, write down the oxidation half reaction. You're just collecting marks. Remember, on the table, I've written all this when you're using that set method. So you're able to just write the oxidation half reaction like that. The cell notation, remember, on the cell notation, already when you know that, okay, this one is on the anode. So on the anode, we are starting with, we said all clever learners. So we're saying now, on the anode, we have Mg, forming Mg2 plus. I always get learners who are asking, do I have to balance the reaction when I'm writing the cell notation? I said no. Even if you didn't show the 2s and the 3s, you will get your marks. And then your salt bridge, and then you can indicate the concentration of Mg2 plus as 1 mole per cubic decimeter, and you had Fe3 plus here, that is becoming Fe. So you know this is the cathode, this is the anode, this cell notation, and always you can see that cell notation has 3 marks. So cell notation, overall cell reaction, very much important because it carries a lot of marks. And then the name of the component responsible for electrical neutrality of the half cell. Remember, this one we said is the Sol bridge to maintain neutrality. So you will say cell bridge. Calculate the EMF of the cell, which is what we did. Here, we were able to get that answer of 2,30 volts. So you're able to do that, which is the same as what is given here. So you can see everything we've done, and we've done correctly, and you're collecting your marks. Remember, 15 marks, that is 10% of your paper. If you get questions like those and you are able to answer all of them, and then we know that we are prepared and we are ready to move. This question taken from Eastern Cape. Learners were given now the cell notation. They were given a cell. You see, cell notation, overall cell reaction. Those very important because we can use them to give you the question as well. So already you know all clever learners. So you say all clever. So you are able to see, no, this here we're having the anode, which means at the anode, aluminium will lose electrons. Aluminium will lose electrons. That's what happens at the anode, will lose electrons. But on the cathode side, you are having your permanganate ion and Mn2 plus, and they are all aqueous solution. Hence, we put a comma there, emphasizing that again. And we look for platinum because we need a solid as our conduct. Then we put the platinum that side. Now, which one of the following occurs at the cathode? So at the cathode, we know this is what is happening. Is MnO4 minus forming Mn2 plus. So now, at the cathode, we gain, we don't lose electrons. So if we check here, you can see that the electrons are on the product side, which means this is loss of electrons. And this happens at the anode, so this is wrong. On the cathode, we don't lose electrons, which means now we gain electrons at the cathode. So your obvious choice is number B, because that's where we have gaining of electrons. Then you collected your marks and you are able to move. So that is good. This one from Western Cape Metronaut, the cell notation again. So cell notation, overall cell reaction. Please, this will definitely help you. They are saying now a bulb connected across the 2 electrodes initially glows brightly. So we're having a nickel 2 plus and silver ion silver cell. So it's the nickel silver cell that we're having. They're saying initially the bulb is glowing very, very much. Remember, nickel on the anode is losing electrons, and Ag plus on the cathode is gaining electrons. So obviously, as Ag plus is gaining electrons, its concentration is decreasing. And when I've emphasized that when the concentration of the ions in the cathode are decreasing, the EMF of the cell will decrease. So they're asking, after some time, the brightness of the bulb decreases. This is because the concentration of the Ag plus in the cathode is decreasing. So you got your answer. That is number A. You see these questions, most of them now they become familiar because you are doing different types of questions. Now on this one from Metronaut, they decided to give you your half cells. They said the 3 unknown half cells under standard conditions are given in the table below. Metal X displaces Y2 plus in YSO4 minus, that is YSO4, and then solution and metal Z displaces X2 plus in that, and then that is what we have. The first question was define the term electrolyte. Remember, we said when a substance is dissolved in water, it forms ions or it forms solution, and that solution can conduct electricity. Or you can just say it's a solution that conduct electricity through the movement of ions. Use information above to answer the following question. Write down 2 conditions. I'm thinking where you are seated, you are tired of the conditions, but that's how much we're emphasizing them. So always remember the standard conditions. Now, when metal X displaces Y2 plus in YSO4 solution, will Y2 plus be oxidized or reduced? you can see Y2 plus already is oxidized. So what can happen is that it must be reduced because it was oxidized already. It had the oxidation number of Y2 plus, and then what can happen to it is reduction. Now, in this statement, they are saying the following three unknown half-cell standard reaction are given in the table below. So they were given, you remember. They are saying, suppose that metals, magnesium, copper, and nickel replaces X, Y, Z respectively. So they are saying, where you have X, you have now have magnesium and magnesium 2 plus. Where you have Y, you now have copper and copper 2 plus. Where now you have Z, you now have nickel and nickel 2 plus. That's what this question is saying. So nothing that must be a problem to you. The question is saying, identify from these metals above, nickel, copper, and magnesium, a suitable pair of electrodes that will produce an EMF of 2.7 volts. Show your calculations. So this question is simply saying, calculate the EMF of 2, because we only take them in pairs. 2 of the in the above, which ones, when you bring them together, they will give you an EMF of 2.7 volts. That's what this question is asking for. And obviously, if you remember the order, we had magnesium, we had copper, we had nickel. So if you look on the table, you can see magnesium is minus 2.36. And then they are expecting you to get an answer of 2.7. Don't forget, we want the 2 that will form 2.7 volts. So you have 2.36. And then when you go to copper, copper is 2, copper 2 plus 2 electrons is 0.34. And if you check, if you were to add 2.36, for the sake of time, plus 0.34, you can see if your math is correct, it will give you 2.7. So you can see that is the magnesium copper cell, but they said show it through the calculation. So you are able to say, okay, E of a cell will be equal to E cathode minus E anode. So you are able to say, okay, this one, the anode, obviously at the top of the table 4b. So you know that your magnesium is the anode, your cathode is 0.34. So you'll have 0.34 minus 2.36, and that will give you 2.7 volts. And you are able to get that answer with no problem. I hope you are getting used to how to use the table and how to go about it. That's what we have done there to show you the answer in the marking guideline. Now, with this remaining time, we're going to focus now on electrolytic cells. We do 4 electrolytic processes, electrolysis processes, which is decomposition of copper chloride. I want you to have an understanding, which is breaking down, to decompose. We are breaking down copper chloride. So in this one, we want to form copper and Cl2. Just have that in your mind. And if you want to form copper and chloride and Cl2, it means these are the 2 reactions that we must have as our products. So when you go to the table, you're just looking for 2 reactions that forms copper and Cl2. And those are the 2 reactions that we expect you to understand in terms of this topic. So I'm hoping you have it in your mind to say this is what we want. Because if you check on the table, you will have seen that if you have your table there, you will see that the copper is given on the table as copper 2 plus 2 electrons forming copper. And then that is positive 0.34, and then you are having your 2Cl minus, that is a negative. I'll check. You have your Cl2 plus 2 electrons forming 2Cl minus, and you are simply looking for 2 reactions that forms copper and chlorine, which means the forward reaction of this one forms copper, which means here you will write your arrow forward because it will form copper. And on this one, you will write the arrow backward, which means on the anode, you'll have 2Cl minus forming Cl2 plus 2 electrons. On the cathode, you'll have copper 2 plus 2 electrons forming copper. And that's what we are expecting of you to understand. Now, on the electrolysis of concentrated sodium chloride solution, on this one, we are saying now Yes, we have seen on the anode, because we are having sodium chloride, and you have done what we said we call hydrolysis when you're doing your acids and bases, and we said, okay, when you put a salt in water, it will ionize, which means when you put sodium chloride in water, it will form sodium plus, chlorine minus. Don't forget, it's in water, so there is water, there is chlorine minus, there is sodium plus. That's where the competition is. And we are saying this one, the halogen, will always be at the anode. Don't forget that. Your chlorine will always be at the anode. So you know the reaction for the anode already is 2Cl minus forming Cl2 plus 2 electrons. Now, the question is, will the sodium plus accept electrons, or will the electrons be accepted by water? And you will see that it is 2 water that reacts with the 2 electrons to form the hydrogen ion and the OH minus, the 2OH minus. So please don't forget that, to say at the anode, if we have chlorine in these two processes, which is decomposition of copper chloride and electrolysis of concentrated sodium chloride, Cl2 will always be formed at the anode. So that one, have it in mind. So you know that at the anode, the reaction remains the same. It's this one and that one for the two reactions, for the decomposition of copper chloride and electrolysis of concentrated sodium chloride. At the cathode of the copper one, it is the copper 2 plus that gains electrons, which means copper 2 plus is a stronger oxidizing agent than water. Remember, in both reactions, there is water. So copper 2 plus is a strong oxidizing agent than water. It will gain electrons. In this case, water is a stronger oxidizing agent than sodium plus. That's why water will gain electrons, not sodium plus. Please don't forget this. This is a question that even if we check, many provinces are asking this type of questions. Now, when it comes to electroplating, I want you to move with me here. When it comes to electroplating, what we are saying that we'll have the metal and the metal ions. For example, let's say our metal is silver. So you'll have silver ions and silver. If you check the statement, we'll say we want to plate a spoon, which is an object. Width, that width is which reaction will take place. And if we say with silver, so it means we're having silver ions and silver. Now, the understanding that we want you to have is this one. During this process, the width part, if we are electroplating with silver, it means the only reaction that we're having, if you go to the table, you will look for silver ion, you will get silver ion given like this. On the object side, there is no reaction except plating. It's like when you are painting something, a wall. The wall is not doing anything. It's just waiting for the paint to be plated on the wall. That's what we are doing. So you simply write your Z on that one reaction. Remember, we're writing the Z on the two, the anode and the cathode. Now, you simply write the Z and say the first reaction which reverses is happening at the anode. The second reaction that is going forward, it's happening at the cathode. So it means on the anode side, you know that it will be silver. It starts from here. It will be silver forming silver ion plus an electron. On the cathode side, you are writing this reaction the same way it appears, which is silver plus an electron. Remember, we don't want you to write two arrows, always one arrow. So you did that question and you understand electroplating, and you are saying the concentration of the electrolyte remains constant. It remains the same. Why? Because you can see that the rate of oxidation and the rate of reduction remains the same. So we have equal rates of the rate of oxidation is equal to the rate of reduction. So you're just doing that. The same with purification. When you say purification of copper, what that statement is telling you is that we are having a reaction of copper 2 plus 2 electrons forming copper. You will do the same. You will write your Z. And you are saying the first reaction is on the anode, the second reaction is on the cathode. So you are able to say, okay, on the anode, copper will lose electrons. You are going backward. Copper will lose electrons. And on the cathode, copper 2 plus will gain electrons to form copper. And that's how purification occurs. Remember, we can change We can say we want to purify something else. It's still fine, whatever that we are purifying, but you will take that direction, the way it appears on the table, that direction of what you are purifying, and then you are able to make the Z and show that the anode one is going backward and the cathode one is going forward. We are done in terms of these 4 processes. You are able to do that. I hope it will help you as we answer some questions. But before we start this section, we are saying don't panic. What are we saying? We are saying remember on galvanic cell, we're saying the positive one is our cathode, the negative one is our anode. In this case, when you say don't panic, we're saying positive now, we call it anode. Negative is called cathode. Remember now, this is electrolysis, which is a process where electrical energy is converted to chemical energy. Please, learners, don't make a mistake of confusing this with motors and generators in paper 1. We don't talk about mechanical energy here. We talk about chemical energy. And then we're saying don't panic. Positive is anode, negative is cathode. So we're able to move. We can use the table in order to do some of the questions. And then as we move forward, free state paper, what is the energy conversion in electrolytic cell? So you are able to say, okay, this one is from electrical to chemical. We are using electricity, hence we have a power source. You can see we have a power source. That shows that this is a non-spontaneous process. It's a process that is forced. We're using electricity to force the positive anode to lose electrons. Remember, a positive doesn't want to lose electrons, but because of the electricity, the direct current that we're using is able to take the electrons from a positive anode and give those electrons forcefully to the negative cathode. So you are able to say that, and then we're saying it's from electrical to chemical, it's non-spontaneous. The simplified diagram below represent electrolysis. You can ask yourself, what is electrolysis? Electrolysis is a process. Don't forget, electrolysis is a process where electrical energy is converted to chemical energy from E to C. On the name there, it can remind you that is 2 marks for the first question. Which electrode is the anode? Remember, we talked about this to say on the anode, that's where our chlorine will be formed. And we said the positive is our anode. Positive is anode. Don't panic. Positive anode. Negative cathode. So you see that the bigger one is a positive, the smaller one is the negative. So you're able to look at that, and we're saying which electrode is the anode, right? Only X or Y. So you're just looking for positive because we said positive is anode. You see that panic, it gave you 1 mark there to say the positive is where X is. So you're able to say, oh, anode is X. Now, write down the half fraction that takes place at electrode X. You know that where chlorine is positive anode. We said on that one, the 2Cl minus, the Cl2 is formed. So you just write the reaction that forms to Cl2. So you're able to say this is the reaction that takes place at X. At Y, remember we said sodium plus is not a stronger oxidizing agent than water. So water is the one that will gain electrons. We just talked about that now. So you're able to write 2 water plus 2 electrons forming the hydrogen gas and the 2OH minus. Look at the marks we are collecting. 2, 2. We have 4 marks for that. A current, you see now, you have seen that we're evolving, we're moving towards geometric calculations now, and you see that our examiners now, they're asking us to do questions that involve the current and the charges and the molar volumes and the number of particles, all that grade 10 and 11 information, you are able to utilize it. Look at 9.4. It's saying a current of 0.5. Immediately when you see current, you know it's the rate of flow of charges. I equals to Q over T. That's what comes to your mind. It's applied over a period of 5 hours. Oh, you know, we have current is 0.5. We have time is 5 hours. Remember, our time has been seconds. And to do that, to convert, remember 5 hours, how many minutes in an hour is 60. How many seconds in a minute is 60. So you'll say 5 times 60 times 60, and that will give you our time that we're having, and that will be multiplied by 0.5, which is our current. So that's what we are expecting. But look at the question. The question is saying calculate the volume. You can see that whatever information we have is not talking about volume of chlorine gas at standard temperature and pressure. We have standard conditions there that is formed during this time. So you can see that immediately when you say volume, when you say STP, the equation that comes to your mind is N equals to V over Vm. And that tells you that you need to first know the number of moles. You must know the number of moles. Remember, you were able to calculate the charge. So this is a process where you know that N equals to Q over QE. And you know that the other formula, N equals to N over NA. So all these which I'm writing on the board, these are the pieces of puzzle that you are going to join together in order for you to answer this question and get that 6 marks. So I'm hoping that you will be able to do that. As I indicated, the first step will be for you to write the formula I equals to Q over T. You substitute, and then the 5 times 60 times 60 gives us 18,000. You multiply that by 0.5, it gives us 9,000 coulombs. So we got the Q. Immediately when we have the Q, we look for the formula, and then you know that Q, which is 9,000, over charge of an electron, which is negative 1,6 times 10 to the power minus 19. We have a positive charge there. Don't write it as a negative. Just write 1,6 times 10 to the power minus 19. And then you're able to say 9,000 divided by that. You get the number of electrons. Please, learners, don't think that this N, usually I will just write bigger ones to try and differentiate from the other one. Don't think that this N you are calculating here is the number of moles. No, it's the number of electrons. So immediately when you got your number of electrons, which is the same as number of particles over Avogadro's number, that formula N equals to N over Na, you are able to get your number of electrons in this case, and then you use the number of moles of electrons. You are able to use N over Na, which is the number of particles, which is in this case the number of electrons, which is 5,625 times 10 to the power of 25 divided by Avogadro's number, and then you are able to get 0,093 moles. And then you are able to say now the mole ratio there. We are saying that for the chlorine, we have those the number of moles is 1:2, and then we are able to divide that by 2, then you get 0,0465. From there, you can now use N equals to V over Vm, which now we know that our N we've calculated is 0,05465. And then from the data sheet, our molar volume, your 22,3, 22,4 in this case, and then you multiply that, you get your volume as 1,04 cubic decimeter. I'm hoping that you will continue to practice questions related to this one so that we don't have problems. You are able to do this stoichiometry. It's just they just around the same. It's not something that is different. Now, this question is saying which one of the half reactions below will be the main reaction at the cathode during the electrolysis of concentrated sodium chloride. Already we said chlorine Cl2 forms at the anode. So, and we said sodium plus is not a stronger oxidizing agent than water. So definitely it must be water gaining electrons to form that, which is number C. I'm trying to be fast so that we have done this question before, you have seen it. And this was the paper from KZN. Define the term electrolyte. You see, you are still telling us here it's a solution that conducts electricity through the movement of ions. Which electrode, M or N? I like this question because they gave us the graph. So you can see that there is now for mass of electrode M, you can see that it's increasing from 12,52 to 17,85. And we said when we started that the mass that increases is the mass of the cathode. So definitely M is on the cathode, which means M is on the cathode, which means N would be our anode. How do we know that M is the cathode? Its mass is increasing. There is increasing mass, which means we said positive is anode. So the bigger one is like that, and the smaller one is like that. So you can even show it like that to say this is negative, this is positive, because you are saying positive is anode, negative is cathode. So the problem becomes even much easier for you. You can see now is electroplating. They are saying electrolytic cell used to electroplate an iron bar with, remember what I said, when they say with, all you have to do is to say the only reaction that is taking place here is the copper 2 plus 2 electrons. This is how it appears on the table, forming copper. I said you write your Z and you say at the anode we go backward, at the cathode we go forward. So you're able to say the first question was which electrode M or N represent the ion bar. So the ion bar must be here at the cathode, will be your M. Why? Because it's the one that is being electroplated with your copper, because it's increasing in mass. But it is observed that the concentration of the electrolyte remains constant. We talked about this to say during electroplating and purification of these metals, the concentration of the electrolyte, as long as we're using this one reaction and saying the first one goes backward, the second one, anode goes backward, cathode goes forward, we said that the concentration of the electrolyte remains constant because the rate of oxidation is equal to the rate of reduction. Now, as I move towards the completion of our lesson, to say in this question now, they're saying calculate the value of X. So you can see that this question is not going anywhere. Calculate the value of X as shown on the graph if a constant current of 1,5 amperes is passing through the cell. So already you can see that current is given. Current is 1,5 amperes, and you know when you have current you can find the charge, because I equals Q over QE, and then you are I equals Q over delta T, which is this one, and then you can go to number Q over Q, charge of an electron. I mean Q over T as our first equation, and then you are able to get your charge. But in this case, we want T. We only have this, which means we must first find Q. And you know that the number of moles, the N equals to Q over Q, will come into place as well. And these are the formulas that you are going to use to be able to calculate this question. So the main thing here that I want to emphasize as we conclude is to say you could have seen already that our mass increased from 12,52 to 17,85, which means now this change in mass here, we can use it to calculate the number of moles if we want to solve that problem. Because the number of moles, once we have the number of moles, then it will help us in order for us to finish this type of question. In this case, you will have found the difference in the mass. You will have found the difference in the mass divided by the molar mass of your copper, which is 63,5. And then you do the mole ratios there, and then you're able to get that the number of moles is 0,168. And then using that formula, N equals to Na over N over Na. The formula N equals to N over Na. You use that one. When you substitute, you are able now to get your N, and then you can use the Q, the charge as well. Then you are able to do that and calculate your time. I know that we have been trying to be fast in terms of this question, but as I conclude, I would like to say to yourselves that the main thing is that we were given the mass as we started with this question. And where did we get the mass from? We got the mass from the change in the table of our cathode. And then we are saying that you will find that change, you divide it by the molar mass in order to find the number of moles of those electrons. And then we are saying there are 2 electrons, hence that, then we use that mole ratio to get the number of electrons. And then after that, we are able as well to go and find a number of moles equals to number of particles over Na, and then we have Na and we have our N there, and then we are able to use that. Then we go again, we look for the charge as we've done in the other question. We got that our charge is 16,176 coulomb, and then we can now simply calculate the charge, which is I times delta T. In this case, the charge was 16,176 equals to 1,5, which is our current that was given initially. And then we're able to calculate our time as being the last one here. I won't be happy if I close this session without talking to this question of 9.5, which is our last question for the day. It says, it is observed that the iron bar is not coated with zinc. Explain this observation in terms of the relative oxidizing strength of the substance. Now, if you go to the table, for example, let me go back to the table. Yes. Now, if you check, we are having zinc and copper. The copper, the 2 plus, which is 0.34. So we're having that. And we're having our zinc, which is negative 0.76. Just take it from here because we don't have time. But I want to explain this. It says zinc 2 plus 2 electrons forms zinc. And we said this is negative 0.76. And we're saying copper 2 plus 2 electrons forms copper, which is positive 0.34. Now, the question is saying use why zinc is not the one that is formed. The thing is, now the presence of zinc, if you check on the left, we said we have oxidizing agents. And the strength of oxidizing agents increases when we go down from zinc 2 plus to copper 2 plus. On the side of this side, on the right hand side, we have reducing agents, and they increase as we go up. But this question said use the oxidizing ability to explain this question. So you must focus on this one. Why zinc is not formed but copper? So you're going to say copper 2 plus is a stronger oxidizing agent. In full, it's a stronger oxidizing agent than zinc 2 plus. Hence, copper 2 plus will be reduced. Copper 2 plus will be reduced to copper. Hence, copper is formed. Please, learners, this question is always almost there. So I would like you to always look at that and not lose that 3 marks. If we're saying use oxidizing ability, it means you'll go to the left and compare apples with apples. You can't now compare zinc 2 plus and copper. No, it must be what is on the left is the oxidizing agent that you are comparing. What is on the right are the reducing agents that you are comparing. I hope this lesson has opened your eyes and you will continue to do as many questions as possible. And without any wasting time, I will say thank you for watching this lesson. See you next time. Goodbye.